exponent tells us to take a number and multiply it by itself a certain number of times. In other words, exponents are basically repeated multiplication. Let me give an example. This is an exponent, 2 to the power 4th. Let me tell me something about why it looks like that. I mean, why the numbers are different size. First of all, we need to know that this exponent tells us to take the number 2 and multiply it by 4 times. 2 times 2 times 2 times 2, which is equal to 16. Exponents involve two numbers. The first number is the one that gets multiplied repeatedly a certain number of times. 2 times 2 times 2 times 2, and it's written full size and it's called the base. The second number tells us how many copies of the base to multiply together. It is written much smaller and up at the top of the base like this, and it's called the exponent. 2 to the 4th power. We read this exponent usually 2 to the 4th power, or just 2 to the 4th for short. For example, 2 to the 3rd will be read 2 to the 3rd power, and 2 to the 5th will be read 2 to the 5th power, or just 2 to the 5th. 10 to the 7th, this exponent will be read 10 to the 7th power, or just 10 to the 7th. The most common exponent. We will very often see 2nd power or 3rd power. Those exponents so common that they even have special names. When a number is raised to the 2nd power, we say it's being squared. Let me give an example. So, 3 squared, 3 to the 2nd power, also referred to as 3 squared. 6 to the 2nd power would be 6 squared. Why we use the term squared? Let me explain it. For example, we want to calculate the area of this square shape. Since the square have sides all the same length, if you multiply that length together twice, like 3 times 3, it gives the area of that square. Also, we can write them as 3 to the 2nd power, also called 3 squared, is 9. For numbers that are raised to the 3rd power, you would say that the number is being cubed. Let me give an example. 2 to the 3rd power is called 2 cubed, and 5 to the 3rd power would be 5 cubed. Since cubes are three-dimensional objects with sides that are all the same length, if you multiply that length together 3 times, you would get the volumes of the cube. In this example, the volume of our cubes 2 times 2 times 2 or 2 cube also is equal to 8. So squaring a number gets its name from squares, and cubing a number gets its name from cubes. Exponent operations do not commutative property. I mean, you can't switch the order of the numbers without getting a different result. Let me give an example. 2 to the third power is 2 times 2 times 2, which equals 8. But if we switch the numbers, I mean 3 to the second 3 times 3 is equal 9. So exponents do not have the commutative property 2 to the third power is not equal to 3 to the second power. 8 is not equal 9. Remember, exponents are the way of doing repeated multiplication. 2 to the second power is the same as 2 times 2. 2 to the third power is the same as 2 times 2 times 2. 2 to the fourth power is the same as 2 times 2 times 2 times 2. And 2 to the fifth power is the same as 2 times 2 times 2 times 2 times 2. Exponents can save you a lot of writing when you need it to show repeated multiplication. Exponents can be any number, 3 to the power 64th or 11 to the power 236.